Welcome to Altair Engineering Training Support. I am Apur Bapat. Welcome you all in Solid Thinking Inspire 9.5 training series. So we'll start with the training series schedule. I have already covered session 1 to 12. In these sessions, in first three sessions, I have discussed about the license application of Solid Thinking Inspire, download and install of software of Solid Thinking Inspire 9.5, and how to activate the license of Solid Thinking Inspire 9.5. Then in session 4, 5 and 6, I have discussed about the options available for basic operations, modeling operations, optimization operations in Solid Thinking Inspire 9.5. Then in session 7 to 12, I have discussed the tutorials like getting started, moving and snapping, sketching and optimizing a bridge, exploring multiple load cases, preparing CAD geometry, defeaturing a model. Now in today's session, that is session number 13, I am going to discuss about minimizing a mass load case, how to solve that tutorial. And then in the last session, I am going to discuss about the saving and exporting file. So today we are going to see running and optimization with an objective of minimizing mass, then applying an extrusion shape control, then applying stress constraints, applying displacement constraints, and evaluating the results of optimization. So let's start with the opening of STInspire 9.5. To open Solid Thinking Inspire 9.5, go to Start, All Program, HyperWorks Student Edition, Solid Thinking 9.5, and click on Inspire. We'll open the model, rear set bracket. This is a model in which the loading of standing, as you can see, is already applied, and also the loading of braking is already applied. So you can see the different loading cases is already applied on this. Now we will apply the extrusion constraint on this. So I have applied the extrusion constraint on this. Now I will solve the model for minimizing the mass with a factor of safety 1.2 and the thickness constraint to be 9 mm, solving for both the load cases. So we will solve this first load case, and in the later portion of the session we will see how to apply the different constraints and view the results. So now you can see it has been solved, the first load case. So you can see the results. So what I will do, I will always see the results in the second last option and save the different shapes, and then it will be easy for me to compare the results. So I will save this first shape, creating a new folder, shapes, then shape 1. Now I will solve this same model for the factor of safety 2 without changing anything. I will solve the same model for the factor of safety 2 and see the results. So you can see I have got the second results for the safety factor 2. So I will move it to the second last option and cut down the results, save it as shape 2. Now I will see the design violation. If you put bigger factor of safety, then what happened? So let's see that. Now we will solve it for the higher factor of safety to get a. So whether for this loading condition, for both the loading condition, whether we can achieve this factor of safety by removing the material or not, or minimizing the mass or not, we can see now. So you can see it has given an error. So we will view this error now. So just click on this and it is showing an error that design violation. So if you click on this design violation, the message dialog box appears with which error for the displacement constraint the error is giving, stress constraint, mass target, frequency constraint, for what constraint the error is coming. So you can see it is giving the error for the factor of safety 4. So you can, it is not for this model it is not possible to achieve this factor of safety. Now I will apply a design constraint on this. So I will apply the design constraint on this point for the displacement not more than 0.6 for all the degrees of freedom, and I want this displacement constraint on standing load case. So I want this displacement constraint on the standing load case. Now again I will solve this for the factor of safety 1.2 for on the both the load case with a design constraint activated. So now I have constrained this to displacement of 0.6, so it will not move more than 0.6. So apart from the design stress constraint, I have applied one more constraint as the design constraint. So these are the different constraints which you can apply and get the results. So it has solved this. I will view the results for the second last. So I will again cut this shape and save it to shape 3. So now I have the results for factor of safety 1.2 and minimum displacement constraint, minimizing the mass with a factor of safety 1.2. So now we will see the results. So if I open this, you can see this is the first result. So these are the two different results, one without displacement constraint and one with displacement constraint. So these are the different shapes which you get by providing different constraints and different factor of safety for the same results. So in this way you can solve your model and get the proper and required shapes. So in this way I have ended with this tutorial. Thank you very much for attending this session and also thank you very much for watching this video. Have a great day ahead. If you find any queries or any difficulty in solving or getting any option in Solid Thinking Inspire 9.5, feel free to contact us.